Welcome back! By now, you've had a chance to start playing with real temperature data from weather stations around the country. You have made some graphs of these temperature records. You've seen that we have two powerful statistical tools for quantifying the way temperature changes with respect to time: correlation, or the slope of the best fit line. Let's focus on the slope of the best fit line for a moment. It's a powerful and useful technique. We can use it to find trends in any kind of data that we can load into our spreadsheet. Temperatures, pressures, concentration of trace gases, random numbers. Wait, random numbers? Hopefully you noticed that. Should random numbers have a trend with respect to time? If I have a column of random numbers in my spreadsheet, we wouldn't expect the numbers to have any kind of trend or pattern at all. That's sort of what we mean when we talk about random numbers, right? Well, let's just experiment with that. As it happens, Google Spreadsheets has a way to generate a list of random numbers. What I've done here is I've put a column of these random numbers next to a column of dates. Effectively, what I've done is I've made it look like these random numbers are actually some kind of data. Now, of course, there's not really any kind of pattern in the data. If we check out a plot of these random numbers with respect to time, you see that they don't really show any kind of pattern at all. Then there's a way to have the software produce another set of random numbers and make all the necessary changes in the graph. And you can see that when I do that, we still have no real discernible pattern, which makes sense. These are just random numbers after all. But just because these numbers are random doesn't mean that we can't compute a best fit line for them. It's perfectly possible to try, but before we do, let's think about what we would expect to see. Since there is no pattern in these random numbers, we would hope that the slope of the best fit line would be 0. There is no trend in the data when the data are just random values. So let's try it. I have Google Spreadsheets plot the best fit line on the graph of the random values. To help interpret what we're seeing, I'm having Google Spreadsheets also show us the equation of the best fit line. This part over here is the slope of the line. Just looking at that best fit line, we see something interesting and maybe unexpected. The slope of the best fit line is small, but it isn't 0. There is some small trend in the data. By looking at the equation for the best fit line, we can see that the slope of the best fit line is not 0. It's small, but it's not 0. What's going on here? Well, this has to do with the fact that these random numbers are just a small sample of numbers. Over a short string of random numbers, just by chance, you can end up with small trends in the same way that when you roll 3 dice, sometimes you'll get 3 numbers that increase from first to second to third. It doesn't mean that the dice are loaded or anything like that. It was just dumb luck. If you had a different sample of 3 rolls of the dice, you would get different results. So back to this spreadsheet with the random numbers. Just by dumb luck, when we picked some random numbers to use as our fake data in this example, there was some small trend. Not a big trend, but some trend. I wonder what would happen if we forced Google Spreadsheets to pick another set of random numbers. Let's try that. Hey, look. Just by looking at the plot, I can see that the trend, that is, the slope of the best fit line, is pretty close to 0. But once again, that trend in the random numbers isn't exactly 0. Let's try it again. And again. And again. And wait a minute. This one looks different. These are still just a bunch of random numbers, but this doesn't look like no trend or only a very small trend. That's a surprisingly big trend, and it happened completely by chance. Just like sometimes when you rolled the dice and you got a stretch of increasing numbers, in this case, just by dumb chance, we ended up with a set of random numbers that had a surprisingly big trend in them. So what we're seeing is not only is it possible, even likely, for random numbers to have a trend in them just by dumb chance, but also that the computed trend can be surprisingly big. And that has consequences for the trends that we are computing with regard to temperatures and global warming. You see, when we're working with some temperature data from some weather station or another, we now know that more or less no matter what, the equations that calculate the best fit line are going to end up finding some slope. It's not going to be zero, even if there isn't really a trend in the temperature data at all. Therefore, what we really want to know when we're trying to figure out if there's a temperature trend in these data is this. Is this trend bigger than what we would expect by random chance? This, as it happens, is a common question for scientists to answer, and there are whole subdisciplines within the study of statistics that have created techniques that we can use to answer that question. Using huge amounts of math, statisticians can determine the distribution of the slopes that you would find just using random numbers. Perhaps not all that surprisingly, it looks like a bell curve. Let me give you a sense of what that means. Here's another spreadsheet in which I'm plotting random numbers against time. Again, these are random numbers. There shouldn't be any trend in these data at all, but of course there is always some small trend, as you can see in this inset graph. Now on this other graph, what I want to do is build a histogram showing how often different trends showed up. So for example, for this first set of random numbers, we can see that we get a trend of 0.0248 degrees Celsius per year. Therefore, I'm putting that one in the bin of my histogram associated with slopes between 0.02 and 0.03. Let's draw another set of random numbers, take a look at the trend associated with these guys, and add one to the bin that this slope belongs in. Let's do it again, and again, and again. After a while, you can see that a pattern starts to emerge. There is a distribution to the slopes that we find in random numbers, and that distribution is a type of bell curve. Almost all of the time, the trend in the random numbers is very small. However, notice the tails of the bell curve. There have been some times in which I got some pretty impressive slopes with my random numbers. It didn't happen a lot, but it did happen from time to time. Notice too that half of the time the trend will be positive and half of the time the trend will be negative. So, when we compute the trend in a data set, we need to compare it to the distribution of trends that are found in random numbers. Our trend that we are going to find is not going to be zero. Therefore, the question is the trend that we are seeing in the data all that different from what we would be seeing if the data were like the random numbers and didn't have any trend at all? If the trend in our data is small enough that even random numbers might have a trend that big or bigger, well, that means the trend that we're seeing isn't really all that significant, right? I mean, even random numbers with no real trend at all have a pretty good chance of looking like that. We're only going to get excited about a possible trend in the data if we find out that that trend is greater than what would have been likely from random numbers with no trend. So if you have a data set and you can compute the trend in the data using the equal slope function, or alternatively you can just let Google Spreadsheets put the trend on the plot for you, either way, call that trend B. This B is not going to be zero. The question is it far enough from zero that we can say that it is statistically significant? That is, are the odds that we would get this value by chance with random numbers small enough that we can rule out that possibility? Before we actually figure out how we are going to check on this though, I want you to follow the link at the bottom of this page to advance to the next quiz. Answer those questions and then move on to the next video.